We've been working with polynomials, and you have some geometry experience in your life and some more experience coming up next year, hopefully. We're going to see how these two can go together, and we're going to feature addition, subtraction, and multiplication, things that you should be pretty good at by now with polynomials. So let me show you a very basic situation. Bring back your good old days from elementary school. If I had to find the area of this rectangle, I would simply say length times width. Well, if I want to do the same thing, but now I have polynomials instead of good old integers, it's still the same thing. If my length, instead of being 10, is some expression, 8x minus 3, and the same thing with the width, instead of it being 7, let's say it's 2x plus 5. I still use the geometry area equals length times width, but now instead of writing the ever convenient 10 times 7, I write the, kind of gross, 8x minus 3 times 2x plus 5. Then of course you know from your from your algebra that when you're multiplying two like that, you do the sending your swooshes, and you won't get an answer nice and pretty like a 70, but after I do that, I get this, and I see, hey, this and this are like terms, so I can put them together to get that. This one doesn't have a like term to match up with, neither does this one, so my final answer is this. This is the area of that rectangle. It's just written in polynomial form rather than good old integer form. Okay, so now let's switch the situation. Let's take the same situation, but now let's think about perimeter. Perimeter simply means add up the length of all the sides. So if you were going to construct this, how much board would you need to construct this rectangle? Well, if I'm doing perimeter, it's 10 plus 7 plus 10 plus 7, side plus side plus side plus side. Now you might know some shortcuts, like some people might say 10 plus 7 and then multiply by 2. That's totally fine. So now if I'm going to find the perimeter of this rectangle down here, I'm just going to add up all the sides. It's going to look messier, but it's still the same. Side plus side plus side plus side. There's a lot more to deal with though. I've put a little squiggly under all the like terms that have an x variable, and all of those would add up to 20x. Then I put an arrow underneath the like terms that are just integers, and if I do a negative 3 plus a 5 minus a 3 plus a 5, I'll end up with 4. The perimeter, or the distance around that rectangle, is 20x plus 4. You might not like it because you love integers. Now we've done those first two examples with a rectangle. Well, we could use a triangle, we could use a trapezoid, we can use any geometric figure from your geometric past. And just as an example, I'm going to use a square with a side of x plus 3. And a square can give you a little bit of shortcuts. So if I wanted to find the perimeter, I could do x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. But then someone might say, you know what, instead of doing side plus side plus side plus side, why don't I just multiply one of the sides by 4? There's one of the sides. Multiply by 4, I would do the distribution with the nice swooshes, and the perimeter of that square is 4x plus 12. I got it with a little bit of a shortcut, which is totally legal. I can go the long way if I want. I'm still going to get the same answer. The same thing with the area. Traditionally, area is length times width, but in a square, sometimes people say side squared. For example, if I had a square with sides of 5, you would know the area is automatically 25 square inches, I'll say, because you say take 5 times 5, 5 squared. So in a case like this, when I have a square with the side of x plus 3, I can say x plus 3 squared. Well, x plus 3 squared is a polynomial that if you feel like it, you can write out as x plus 3 times x plus 3. As soon as you do that now, you can go ahead and do all the swooshes. Swoosh, 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 swoosh. And you get this polynomial that you can add like terms together, and you now have the area of your square. The point of this last example is to just remind you that anything you know about geometry, you can do with polynomials, just like you would do with integers. And sometimes you can see a shortcut. In the case of a square, there's plenty of shortcuts, so go ahead and take them. That's it.